All right, and we are back. Yeah, let's get going. Okay, so the first thing we want to do when graphing rational expressions is to simplify first. I want to factor the numerator and the denominator. All right, so I have x plus 5, x minus 2 on top, and x plus 2, x minus 2 in my denominator. Okay. Next thing I want to do is figure out, okay, what can cancel out? The minus 2 or x minus 2's cancel. Well, that tells me right away that I'm going to have a whole at x equals 2. Okay, but a lot of us forget this step. We must input it back into this portion, the x plus 5, x plus 2, to get our y coordinate. So I do 2 plus 5 over 2 plus 2, which gives me 7 over 4 for the y value of my whole. Okay. Well, I also need to think about, all right, is there, what is, if, wow, let me start over. So I also want to think about my vertical asymptotes. All right, vertical asymptotes occur once the wholes disappear, meaning I canceled out my repetitions, so my vertical asymptote is at x equals -2. After I simplify, okay, then I identify my vertical asymptote. All right, which helps me a lot with my domain. Okay, my domain is now going to be from -infinity to -2 because I have a vertical asymptote there. From -2 to 2 because of the whole. And from 2 to infinity. All right. Don't forget my little unions there, union. Okay, a lot of us forget to include the whole, our wholes in our domain. A lot of us forget to include the vertical asymptotes as well sometimes too. So be careful with that. All right. To find my x-intercepts are when my numerator equals 0. Okay. If I cancel out my whole factors, the factors that create a whole, I'm going to set the remaining factors equal to 0 and solve. So I have -5, 0. Where does my whole, or where does my numerator equal to 0? Okay. Horizontal asymptote and slant asymptote. I did this last on purpose. All right. Horizontal asymptote and slant asymptote, I want to look at whether or not my equation is top heavy, bottom heavy, or even heavy. Okay, remember, if it's top heavy, that means we're going to have a slant. If it's bottom heavy, it's going to be y equals 0 for horizontal asymptote. And if it's even heavy, I take the coefficients, okay, the leading coefficients, and I take a ratio of those leading coefficients. Well, it's not top heavy, so I would write, not that, I would write none. Okay, because I'm such a good student. You know, as you know. Well, look, it's even heavy. I have x squared on top and x squared on the bottom. The degrees match. Okay, so I have an even heavy rational function. The leading coefficient of those terms is 1 here and 1 there. So my horizontal asymptote is y equals 1. All right. Now I want to take all this stuff and graph my important information. Okay, so I have -5, 0 as an x-intercept, so I'm going to graph that. I have y equals 1 as a horizontal asymptote. I have x equals -2 as a vertical asymptote. There's a whole at 2, 7 over 4. Now this is really hard to draw because this is so thick, but really this whole should be like right in there, okay, at like 1, all right, above, in between the 1 and the 2. That's the best I could do. All right. I can also calculate a y-intercept of about 0 here, 0, 0, 0 for x's. All right, I have negative 10 over negative 4, which is 5 over 2, which is 2.5. So I also have that there. All right, but you can get that by plugging this into your calculator. Okay, so to see the general shape of our rational function, I want to input this into my calculator. Okay, and I need to be careful in my y equals that I use parentheses around everything in my my numerator and around everything in my denominator. Okay. And if you do that, your graph will look something like this. I'm going to try to make a break at our major parts of our graph. Boom, something like that. All right, here we go. Next one. Find the sum, show all of your work. Please leave it exact, no decimals. Okay, so I want to find the sum from n equals 3 to n equals 6, which means I need to find the third term, the fourth term, the fifth term, and the sixth term, and add them all up. Okay, so let's find, I'm going to do in blue, let's find the third term. The third term I'll do by plugging in 3 for n, which 3 minus 2 is 1, so I get 5 over 1, which is just 5. Fourth, 4n for n, which is 5 over 2. All right, I'm going to pause it for a second and do 5 and 6. So here's what I came up with for 5 and 6. 5 minus 2 is 3, 6 minus 2 is 4. All right, so now when I add these numbers together, I want to be careful in my calculator that when I'm doing the sum, I want to do it like 5 plus parentheses 5 divided by 2 plus parentheses 5 divided by 3 plus dot dot dot. Okay, 5 divided by 4. Why wouldn't I just do the last one? I don't know. 5 divided by 4. All right, and then press enter. Be careful. All right, make sure you put those parentheses around your fractions. I got 125 over 12. Now you're going to have a weird decimal. Just press math, enter, enter. Math frac. It's the first one. And I'll give you the fraction. Find the 12th term of the sequence whose nth term. Okay, so here's our general form of our sequence. And we want to find the 12th term. So I want to find a sub 12. That means I'm going to plug in 12 wherever I see n. All right, so this is going to be negative 1 to the 11th times 12 minus 4 is 8. Which gives me negative 1 to the 11th, gives me negative 1 times 16. So my 12th term is negative 16. All right, be careful about your order of operations. When you're doing these problems, be careful to leave these two things separately. All right, when plugging into your calculator. Really, you could do this in your head. I did this in my head. Okay, you don't need to use your calculator really for this one. Maybe do the negative 1 to the 11th, but when you do this in your calculator, you must make sure that you have negative 1 in parentheses. Anytime we use exponents in our calculators, we need to make sure our negative numbers are in parentheses. Last one. Holy buckets, I never thought it'd happen. Wow. All right, so recursive. All right, our recursive, remember, means that I'm going to use the previous term to help me find my next term. So I'm going to use a sub n to help me find a sub n plus 1. So I want to recognize, is there a pattern? Is there a pattern? Is there some sort of common difference? Well, if you look here, negative 2 to 3, I added 5. 3 to 8, I added 5. 8 to 13, I added 5. I added 5. So to define the recursive sequence, okay, I'm going to take my previous term, so a sub n, and just add 5 to it. All right, and add 5 to it. So in the answer key, it says a sub 1 plus 5. You know, that's, we were just thinking about, okay, if I'm just starting at the second term, all right, if this was a sub 2, we put a sub 1. But if you want to think about the actual general case, I would use a sub n plus 5, okay? If we're given these numbers like this, okay, all right? For the general rule, all right, the general rule is a little different, okay? I want to think about, just like in the video, if this is my first term, this is my second term, third, fourth, fifth, okay? What am I doing to 1 to get to negative 2? What am I doing to 2 to get to 3? 3 to get to 8, 4 to get to 13, 5 to get to 18, okay? A little trick that you were taught, well, if there is some sort of common difference, all right, if it's like, if there's a linear pattern, well, it increases by the same amount every single time, I can infer that I'm going to be multiplying whatever that term number is by that common difference. These will match, if that is the case, if it increases by 5 every single time. So if that happens, well, now we have to play around a little bit. 5 times 1 gives me 5. Well, what do I have to do to 5 to get to negative 2? Well, that tells me I have to subtract 7. Then I'll get negative 2. Well, let's see if that works for the next one. 5 times 2 gives me 10. Well, what do I have to do to 10 to get to 3, which is my second term? Oh, I subtract 7 again to get 3. I'll try it one more time. 5 times 3 is 15, minus 7 gives me 8. So that checks out, so it's 5n minus 7. So a trick for these, okay, another trick, just to re-explain the trick I explained, all right, if there is a common difference, if it's linear, if the pattern is linear, then that number, whatever that common difference is, will be attached to n, and then you play around to find out what the actual general rule is. All right, hope that helped. Happy studying. Until next time, adios.